Alright, welcome all, the first of our tutorials. Being the long way teacher and employing observational learning, what you'll find is that there'll be a lot of worked examples for you to work through. And this is very important because this is the only subject in the university where you'll get to do that. So bear with me as I train you in the various more humble parts of the curriculum. I often mention kindergarten, 6th class, all of that stuff, year 7 and 8. And I don't do that to make anyone feel bad. I say, well, if you can manage those things, then you can manage the next things, which are stage 6 type material and then university level. So it's all a chain. My research area has been about making sure that this is something that someone can do who's had no experience or training in algebra, no experience or training in calculus. Alright, so a couple of basic rules. So if we get most people kind of understand coming into uni that minus times a minus results in a plus. A different sign gives you a minus, regardless of whether it's a multiplication or a division, that's a quotient, and same sign on either side. So that's basically what that says. It says, pretty good. Alright, what about minus 2 plus minus 6? Why would we not just say 2 minus 6? Why isn't the question phrased like that? Because you're adding two negative quantities together. So just noticing those subtle things can often be a help. And yes, once again, if you're at minus 2, 1, 2, and then you're going to subtract 6. 1, 2, 3, 4, 5, 6. You're going to get to minus 8. Mathematicians and statisticians do this. They check everything with number lines. Now we're going to be using number lines for inequalities, so it's about revaluing the little stuff. Okay, revalue the little stuff. Okay, revalue the little stuff. Learn some intuition as we go along. Minus 2 minus minus 6, the big fuss I make about this is if I just pull that part out and I say to you, what am I looking at? What's your mathsy mind's eye seeing? Well, in actual fact, that has a 1 there. This is a huge problem for some reason. Students don't cognate. They're actually going to multiply on expansion minus 1 times minus 6. So minus 1 times minus 6, because that's now seen as a 1, gives you a plus 6, and that obeys this rule here. Minus times a minus is a plus, you see. So that's a very subtle thing, and it's something I'm raising with you because it happens. So try and learn to see a bracket. Anytime there's a minus sign, try and learn to see the bracket and understand that that's got a 1 in front of it. Okay? Like the coefficient of the bracket, which is a bit odd, but there you go. So minus 2 plus 6, so you're adding a positive quantity. Okay? And using the number line to help you when you get stuck. So there's the basic rules. Use your brackets. Then you go ahead and do your powers, and then multiplication, divisions, plus and minus. So in this case here we would do 2 by 3, which is 6. So 6 plus 6 would be 12. Over here we want to make sure that we get that this is minus 2, not just 2. Minus 2 times 8, minus 2 times minus 10. Here we're going the other way. 3 times plus 3 times 6 plus 3 times minus 6. So we've got minus 6 out the front. Minus 3, so it's minus 9. 6 threes are 18. Minus 2 times 8 is minus 16. Minus 2 times minus 10 is plus 20. Look at all the menagerie that we had to get through. Okay, so please be careful when you're doing your, because this is the bit that counts. The answer itself isn't dependent entirely on how you've done this correctly. So inside the brackets, now I could have just done inside the brackets. Minus 3 plus 6 is 3. 8 minus 2 is minus 2. Minus 2 times minus 2 is minus 4. We'll end up at the same place. Okay, so whether you do the bracket operations or do the expansions, it's entirely up to you. You'll get to the same place. So whatever you feel more comfortable with. But just remember that you've got to deal with the minuses out the front. So here we got 6 divided by 3, which is 2. Then we've got 7 minus 2, which is 5. 5 nines are 45. So we get a 7. Be careful, okay? Be careful, because although you can choose to do a particular way, that's important. Now, look, indices are a big part of today's video. So this is minus 1 squared. Anytime you've got an even power, you'll get a plus quantity. Okay, anytime you've got an even power, you get a plus quantity. Now 3 squared is 9. Okay, so we'll get 8 minus plus 1 minus 2 times 9 is minus 18. So 8 minus 1 minus 18 is minus 19 plus 8. So we're going to get minus 11. I think that's the one. Alright, so just be careful of your little parts, because the little stuff will make a big difference in the subject. Okay, it'll make a big difference in the subject. Alright, so we've got a table. Now, I think one of the things that happens here is that this kind of law of exponents can get left behind. So I'm going to show you a little trick. I'm going to teach you this. It doesn't matter, this is not important on one level. It's just an instruction set. We're just going to do a bit of programming. In software development at school, it would have been called a desk check. So this is just a bit of programming. So the first instruction says, take the index out the front. And the second one says take 1 off the index, or minus 1. Very good. And the second part is we're going to add 1 to the index. And then the second part of this one is we're going to divide the term by the new index. Now, why am I doing this? Okay, why am I doing this? Alright, so let's take a look at a simple example, x squared. Let's apply code 1 to x squared. So it says take the index out the front and take 1 off. There you go. So we get 2x to the 1, we get 2x. Very, very straightforward. Nothing too algebraically gymnasticy about that. Let's do this one, x squared. So we're going to add 1 to the index, and we're going to divide by that sum. So we get x3 on 3. Now in other parts of the course we'll learn there's other bits to come there. Alright, so that's very interesting. Now in the doing, the procedure of doing maths, and then you verse that with the concept of what this maths is about. And as teachers we have to do both. As students we have to learn both. I've said in the workshop, explain to me differential calculus in its entirety, but you're not allowed to open your mouth. Okay, so if I'm a little bit cheeky, I can open up my video thing. I think I'm not sure I want to do this, but I'm going to do it anyway. So differential calculus, it's gradients. There they are, gradients. Okay, so those gradients are the concept of differential calculus. Alright, well, having said that, what's going on here? What's all this? Is this related to calculus? So sometimes I get students saying, I wish we'd started calculus earlier. And you know, when I did the linear graphs in the workshop, I made the point that the gradient is the beginning of calculus, understanding that concept, you see? Understanding the concept of M. And then we get to the doing of calculus. And what's it involve? It involves doing gymnastics with algebra. So I've kind of dropped a bit of a hint there, but I'll come back to that. I won't do that now. I just want to focus on the indexes. Alright, so let's do this one. What about the square root of x? Let's apply code 1 to the square root of x. So straight away it requires you to have remembered that this thing is called a radical, and the radical has another form. And the equivalent form of a radical is a fractional index. Oh, there it is there. I see that. I see you. So our pre-work will allow us to change forms. So we'll have to do pre-work on both of these before we apply our little algorithm. So this is x to the half. The new form is x to the half. Oh, so this one gets the same thing, x to the half. Now if we apply code 1, which is just Jason's made up programming algorithm, and code 2, Jason's made up programming algorithm, what we'll see is that we've now got x to the half goes out the front, and then we take off 1. All of a sudden, things are starting to get a little bit heaty, aren't they? Because we've got this adding fractions thing happening. And so adding fractions doesn't go away. It's always going to be with us. So it's just something we need to become really, really skilled at. And it's autonomous. Same family now. Form of 1, see that? Form of 1. And then same family now, so we can just do it over the top. There you go. 1 minus 2 is minus 1 over 2. That's our answer. So this becomes 1/2 x minus a half. Now looking at the indices and looking at how it works, we've learned from our previous work that the minus sign means the reciprocal. There it is, the top part of the quotient. So that's the bit I'm going to get rid of. Now I'm going to split these just to keep it obvious to you that it's there, but in a later example I'm going to join them up now. But I'm just going to invoke the reciprocal, so that gets rid of the minus sign. See, there's no minus on this right hand side here where my cursor is. Over here there's a minus, down here there's no minus. So by doing that, I've invoked that there's no negative, so I'll just have a positive. Is that all you do? Okay, so the next thing of course is the fractional indice. There, where's your fractional indice, please? Oh yeah, we're back to this one. So it's that square root, cube root thing. So we're going to have 1 over a half and 1 over a radical. The denominator goes into there, so it's a square root, and the numerator goes onto the power of whatever the argument is, so x to the 1. So that's how we build that up. So we get half, and that's what you're used to seeing from school, and then finally I'll join them together. Now I'm going to do that in later steps. I'm going to do it all at once. So there's our code 1 applied. Now all of a sudden look at all the steps. Okay, so for people that have not had training or done standard maths or general maths, this is a big deal. I've been out of maths for a while. Just showing you every step so that you can take this away and do it yourself. Okay? Alright, so the next part we want to have a look at is this one over here. This one said add 1 to the index and divide the term. So it'll have its own challenges. So we're going to do the code. So here's the code being done. I'll just kind of ready to do the code. So we're going to add 1 to the index, and we're going to divide the term by that. Oh, okay. So now we've got to deal with, and I really encourage you to get in the habit of hiving off a bit of page space and working on these things by themselves. Okay, what's the form of 1 that we want? It's 2 over 2. That's 1, isn't it? Same form, same family now, so we can do 1 over 2 over 2. So we get 3 over 2. That's our final result. So we've got for our x 3 over 2. Dividing by a divide. Ooh, how do we deal with that? That's a bit tricky. Okay, so how are we going to divide? So any object divided by, there's our quotient, divided by another quotient, in this case 3 over 2. How do we deal with that? What? How do we do that one? So what we do is we just piecemeal it out and use symbols. So we just say, okay, we're going to take that one and we're going to operate on this one. See? And we're going to call it divide by. Oh, so we're just swapping that around. They're the same thing, aren't they? Two forms of the same thing. We love forms because they help us so much. And then, of course, the trick is that we're going to do this one. Now, some of you will be doing that in your head straight away, and that's wonderful for you, but others have never seen this. So 2/3, 2x to the 3 on 2. Wait a minute, where's your 3, Jason? There it is. I didn't lose it. Okay, and we've got this fractional index. Remember, a fractional index has got this form. The denominator, so it's a square root, but it's going to be x cubed. And it stays on the top because there's no minus. So we're going to have 2/3 square root of x cubed. And later on we'll learn there's some other stuff to come with this particular code. Wow, look at that. Fabulous. Okay, lots of gymnastics. We do algebraic and geometric interpretations. That's a key to, that's a journal entry. But this one here, gymnastics. How's your gymnastics going? Algebraic gymnastics. That's a journal entry. Okay, so you've got algebraic and geometric interpretations, and then you've got algebraic gymnastics. So very encouraged to keep moving along. Now, it doesn't take long for us to get it rather complicated and getting into unfamiliar territory. So let's have a look at that. Unfamiliar territory. Let's try and go for one that's a little bit more complicated. Let's take the cube root of x to the 7, just to be annoying. And so what we'll be looking at is the cube root of x to the 7. Now when you look at an expression like this, it doesn't necessarily jump out to you that we've got to do some pre-work, but that's our first instinct. We're building intuition. So we want to employ forms. We want to employ forms to help us out. This is all the stuff I can't do in the tutorial because we're simply not the time. So these videos will run, there'll be a few of them for this. Okay, employ forms. So we're going to go through and do a bit of pre-work. This is the gymnastics happening. Okay, so we're going to go and change the radical to its index form. So the denominator has what's in the nape here. This is called the nape of this symbol, this radical symbol. So it goes on the denominator, and the 7 goes on the top. So that's good, we've moved that. So we've ticked that box, okay? And the next thing I want to do is I want to undo this quotient. This is the reciprocal symbol. So I'm going to bring it up the top. Now if I replace it, I need to replace it with something. So what am I replacing that whole symbol with? Ta-da! There you go. Now we're ready, and all of those things apply there. And now we're ready to do our codes, okay? So we can apply our code to those and everything's good, okay? All right, so code 1 is that we take the index out the front, unfamiliar territory, and we subtract 1 from the code. Wow. Okay, well that's all right, we can do that. Now we've got unfamiliar adding fractions, but because we know what we're doing with adding fractions, this is easy peasy. What's the form of 1? Same family, so it's going to be 3, isn't it? So it's minus 7 minus 3 over 3. Minus 7 3 over 3 is minus 10. Okay, so there you go. Easy peasy. Alright. Now the next thing we want to do here is recognize that minus 7 over 3, x to the minus 10 over 1. Didn't know that was going to happen, but that's okay. So what we want to do now is consider this term separately. So just be mindful of that, because I did it up here, I kept them separate. I'll join one up in a minute. But at this point here, I'm going to deal with the minus sign. According to this rule over here, the minus sign is a reciprocal. So I'm going to invoke that different form. So I'm putting minus 7 over 3. Now I've joined them up, haven't I? I haven't kept them separate. So the x to the 10 over 3 is coming down. Notice there's no minus sign now, it's gone. Okay, very important. The next thing we want to do is invoke the other form of the fractional index, which is 3 radical. And x gets a cube root, but it's x to the 10. Okay, so that's our final answer. Our final answer is, look at the gymnastics of this. Did you like that little trick where I made sure that you understood when you do the operation on the x, you're not doing it to these guys here? And then when I did it, I didn't do 2 separates, did I? I didn't do 2 separates like I did before. Okay, I didn't do that. I didn't do it at all, so I don't know why that pops up. Okay, so yeah, that was just an intermediate step, so I missed a few steps there. Just trying to encourage you to develop your intuition. Alright, so for this one over here, we're going to apply code 2. So code 2 says add 1 to the index. Okay, that's what, if you insist. We're adding 1, there you go, and dividing by that new index. So we better figure out what that is. So now we've got minus 7 on 3 plus 1. What's the form that we're looking for? It's 3 over 3, that's our new one. They're the same. And now we've got the same family, so we can just put them together. There they go. And minus 7 plus 3 is going to be 1, 2, 3, 4, 5, 6, 7. And we're going to plus 3 now. So we're going to go 1, 2, 3. So it's 1, 2, 3, 4. So it's negative 4. So we've got minus 4 on 3. Now I know some of you have done that in your head, but there's no shame in this. There's no excuses. If we can draw, if we can count, we can do maths. So minus 4 on 3 divided by, oh no, Jason, we've got minus, divide by a quantity again. So we've got to recognise, of course, that we're dividing by, there's our divide by minus 4 on 3. So it's going to be divide by minus 4 on 3, which is going to be times minus 3 on 4. Oh, okay. So the numerator gets minus 3 over 4 x to the minus 4 on 3. That can be very confronting. Okay, that divide by divide there can be very, very confronting for students if they've never done that before. But as you can see, if you break things down and just do step by step, it's quite straightforward. So I'm going to deal with the negative. I'm going to join them together. I'm not going to keep them like this, separate. Just going to go for the same. So the minus 3 is going to sit up there like it's kingpin. The 4 is going to sit underneath here, and then we've got x, and there's no minus. The minus has gone on there because that index is this rule. Okay, very good. And then the final thing we've got is minus 3, changing forms, invoking the different form. So we've got the cube root of x to the 4. And in later work we'll learn there's a bit of an addition. So that's our final point. Ooh, wow, what do you think of that? So the most simple things can become quite complicated, okay? But if you get, this is your job. This is the job that you have as a student in Foundation Maths. You must come to terms with what we're doing here today. So you can make these up yourself. You can choose to do, the starting point can be your own starting point, but you've got to get some practice in this. It needs to become autonomous. Please do this. This is not something I want you to stand back and say, oh, I'll kind of do it later. No, no, no. If you're going to survive in Mathematics 1 and thrive in Mathematics 1, you need this. This is your challenge, okay? You must do this, please. Alright, so that was a bit of an anatomy of a laws, wasn't it? And we're not finished because there's more to come. And I'll do one more thing with the laws, and then I'll change the video because that's got a little bit of length to it now. Alright, so for this one here we've got 5 by 3. What do we do with that? Oh, really? Okay. Oh, there it is up there. So we need to build our intuition. We're adding indexes. There's 2, and the 2 become 1, and we sum the indexes. We add them. Okay, 5 and 3 is 8. Okay, so we've got to learn to deal with the forms. This one here, we're going to subtract it. Here we added it, so here we're going to have 3 minus 5 because it's a quotient. That's this rule up here. They're all there. That's that one. Okay, so this is going to be 3 minus 5, so it'll be y to the minus 2, which is 1 over y squared. Okay, whichever form you need to land on, that's the one. Now look at this guy. This is a culprit. This is a huge problem. So whenever we get this one, for some reason, even though it's over here and it's there clearly a part of the exponent laws, get into Maths 1 and they get a question like this, and most of the group gets it wrong. Okay, so what we need to do is recognise that this is a simple proposition. It's a product. So the shorthand is 3 fours are 12, answer. The longhand of this is that any time you have a bracket, that's 4 times. So again, counting them out, you've got no excuse. So A3, I'm doing this the long way teacher because I'm making a video and I can. Wouldn't have time to do this necessarily in class. So that's A3 times A3 times A3, moving the brackets now because the brackets aren't needed. And so A, you can clearly see that. So you can do it the long way if you need to, or you can just learn that. Now the issue is here. What happens if I do something like this? This rule, the one that I'm pointing to about the products, completely describes this, does it? What's your mathsy eye seeing? What's your mathsy eye seeing? Well, the first thing to notice is that the 6 has an index of 1. The Z has an index of 2. That's your mathsy eye working out. Okay? The next thing we notice is that that's got to be multiplied and that's got to be multiplied. So 3 1s are 3, so we get 6 to the 3. And 3 2s are 6, so we get Z to the 6. Okay? 6 6s are 36. 6 6s are 36. 6 3s are 18, 19, 20, 21. So the answer is 216 Z6. Okay? This is extremely poorly done in Maths 1 when students first get there. So we need to get plenty of practice doing that. Okay? So just highlighting that for you. Alright, this one here, let's do this one together again. And I'm going to do a variation of this and then I'm going to stop the video and move on to a new video. How do I view this? What's my mathsy eye? I've got to come up with an eye lens, haven't I? What's my mathsy eye? Actually, you know what I'm thinking? Maybe I'll do a circle and put a question mark in there. What's your mathsy eye seeing? Okay, so we've got to do it like that, haven't we? What's your mathsy eye seeing? Question mark. That's pretty good. That might be it. Okay, develop things on the run. Policy on the hop, as they say in politics. So what's your mathsy eye seeing? Well, what your mathsy eye is seeing is X has an index, Y has an index. Oh, I didn't know that. Thank you, mathsy eye. Very good. Now, what do we do with the divisions? Where are they? There you are. Oh, look, they both get the n. Okay, so that means we've multiplied that index by that index. So we get x to the 4 over y to the 4. How good was that? So again, it's always the variation, isn't it? What about if we have 3m and 2y, so some power? How do we deal with that? So I'm going to refine this a little bit. I'm going to do the circle lens first. Oval, question mark. There's your mathsy eye. You get a little bit of a swoop. Okay, what's your mathsy eye seeing? Your mathsy eye is seeing 3 to the 1, m to the 1, 2 to the 1, y to the 1, all to the power 3. That's what your mathsy eye is seeing. And so we've got all these multiplications to do, and all these multiplications to do, and these are the variations that don't get explained, do they? So we get 3 1s are 3, 3 1s are 3, 2 gets a 3, because it was 1, and y gets a 3. Now if that was some other number, then we would have to take that into account. So 3 3s are 9 3s are 27, 2 2s are 4 2s are 8. So there you go. Alright, we'll do one more of those. We'll do it as 2n4 divided by y6, and we'll call that squared. So do my little oval again with a question mark, and a couple of swoops. What's your mathsy eye seeing? What's your mathsy eye seeing? Your mathsy eye seeing that. Okay, very good. And then your 2 gets times by that index, and that index, and that index. So we get 2 1s are 2, 4 2s are 8, 6 2s are 12, 4 n 8, y 12. Awesome. Okay, so your little mathsy eye, okay, your little loved one is being spied by your mathsy eye. Okay, and what are you seeing? I could put that in a circle. Okay, what are you seeing? All right, so I'm going to do one more example, quite a hard one now. So this will be the hardest algebraic gymnastics you ever encounter in this subject, but I'm going to do it anyway. Okay, so what happens if I do this? I want to get these 2 guys together on the denominator, but how do I get the x under a square root sign? How do I get the x under a square root sign? The hint is up here. Okay, the hint is in the invocation of the radical. Alright, so if I take an equation and I've got a square, so if I've got m squared equals 6 or 9, that's a typical one, isn't it? How do I undo the 2? Well, the undo of that is that you take the square root. Now what you do to one side, you do to the other. Now what's the maths of that? What's the maths of the square root? We know that that becomes m, and the square root of 9 is there. So these 2 guys here are in equivalent form. Dun, 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 dun. So how do I write 6? 6 to the 1. I can write it as 1 times 6. I can write it as some other thing. 1 times 6. It's still 6. Now what we're saying is that if I take the square root of the square of 6, it's the same thing. A new form of writing. Okay, what's the maths of this? The maths of this is m squared. Invoke the different form for the radical, which will be a fractional index. Do the laws. A half times a 2 is 1. There it is. Okay, square root of 9. I could put that side, so I'm focusing on the left hand side. So this is quite an issue. So what's the form I can use? Oh, well, all I've got to do is take the square root of x squared. Oh, look at that. Now that's the same. That there is the same form, same equivalent. It's a new form. Invoke the form. What did I say earlier on? I said something earlier on that I was impressed with. Employ forms. So we're going to employ forms. Okay? Employ forms. Because they're equivalents. They lead to equivalence. Okay? So what that means is that now the maths of that is that I have 2 of these together. And of course what that means is that I can join them together under one big one. Okay? So I'll end up with 1 over the square root of x squared y. So I managed to get that underneath. Now this is an advanced thing. Oh, no, it's for unit students who struggle a little bit with that. In the orientation video, I did an example of something from Maths 1, and I pulled this particular feature out, and I probably rushed through it. But here it is. This is what we did. We did the laws that we did. There's a lot of menagerie, isn't it? A lot of those things. And we're like that as humans. We've got to assemble a lot of threads, and it's not always just nice and neat in the way that we do that. Alright, so I'm going to press pause there and come back and address these guys in the next tutorial video. This tutorial 1 video.